All right, so we are going to go over the practice quiz here for 3-1 to 3-3. So the first question is just two describing the transformation type things. So we've got if f of x is 5 to the x and g of x is 6 times 5 to the negative 9 times x plus 7 minus 14. What's the transformation that happened? So if that's what we have, then we've got a whole bunch of things going on here. One of them, vertical stretch. The negative here is telling us that we are reflecting, and since it's up with the x, that means we're reflecting over the y-axis. And then the 9 is horizontal compression. The plus 7, since it's with the x, tells us we're moving left 7. And then the 14, since it's minus 14 on the outside there, tells us we're going down 14. And that is everything that is happening with that function. All right, so we would need to list all of those things. Actually, I'm just going to move this. The next question. Was very similar. We had f of x in this case is log base 2 of x. G of x is negative 2 log base 2 of 3 times x minus 4. There's a little bit less going on in this one. We've got the negative on the outside telling us that we're reflecting over the y-axis. Then we have the 3 inside, which is telling us that we've got some horizontal compression. And I skipped this one, that's vertical stretch. With the 2 on the outside. And then the minus 4 on the inside tells us we're going right 4. Okay, so that's the basics of the first two there. Any questions looking at one, part A and B? Okay, so that's 1A, 1B. Sorry, thank you. That should be x-axis. I think I said x-axis and wrote y. Thank you for catching that. Yes, that should be x-axis. Okay. Then moving on to number 2, draw a quick sketch of the graph of the functions and then find the domain, range, x or y intercept, increase, decrease, depending on which one has, or which one the function has, and then describe the end behavior. So we had two particular functions that we're talking about here. So I'm just going to jump over to Desmos and graph them. That was from something else. Okay, so one of our functions, f of x equals, it's just the log of x plus 2 minus 1. Okay, so remember for logs, it's the domain that's a little bit limited because we get this asymptote right here. Since it's been moved left 2, our domain for this function is going to be -2 to positive infinity. So we would write our answer -2 to infinity. And then the range, -infinity to infinity, since there's nothing excluded from the range in this. And then we also needed the x or y intercept. In this case, we have both. The x intercept is 8, 0. The y intercept is 0, -0.699. And those you can find just by clicking on them in Desmos. You could also just say 8 for the x-intercept or -0.699 for the y-intercept, because it's kind of implied that the other value is 0 in both of those. We have for interval of increase, since this logarithm is increasing on the entire domain, the interval of increase is just the whole domain. -2 to infinity. And then the end behavior, we have the limit as x goes to infinity of f of x. And then the other end is the limit as x goes to -2, because that's the other end of your domain. So if your domain has, is not -infinity to positive infinity, or if it doesn't have one of those endpoints on it somewhere, then you just pick the lowest value for your left end. And so from the graph, we saw that as x goes to positive infinity, f of x is also going to infinity. As x goes to -2, f of x is going to negative infinity, because that's where it plunges downward. Okay. So that was that first one. Then the second, so that's everything that we should have for that, plus a quick sketch of the graph. It doesn't have to be anything super fancy. You just might want to mark key things like -2, and let's see, the intercept was at 8, and call that -1 so that we know that it's hitting somewhere around there. Oops, can't see that. There it is. So it should look something like that. You can draw this more as going down further if you would like. But you should definitely label things like the asymptote and any intercepts that we have. But again, we're just looking for a quick sketch there. So the second thing that we needed, we had another graph. This was f of x, the other function, g of x equals 10 to the x minus 2 plus 7. On the actual quiz, you'll only have one function that you're supposed to do this for, but on the practice quiz, I wanted you guys to be prepared for both an exponent and a logarithm, so I put both on there for the practice. So let's go ahead and type this into Desmos. (10 to the x minus 2 plus 7). All right, here we go. So this one, notice we've only got a, oops, that's supposed to be -2 in the exponent with it. It's like, why is it there? Oh, come on. Okay, fine, I'll put parentheses around it. There we go. So looking at this one, it's an exponential function. The domain is not limited on an exponential function. So our domain is going to be -infinity to infinity, but the range is limited with the exponential. It's not going to go lower than 7. We've got this horizontal asymptote at 7. So the range is going to be from 7 to infinity here. So that's what we should get for our domain and our range. There is no x-intercept for this, but there is a y-intercept. And the y-intercept was at 0, 7.01, where we clicked on that. And this function is increasing on the entire domain, so negative to positive infinity. This thing is always increasing. So it has an interval of increase, but no interval of decrease. So we have only increase here. Then we need the end behavior, so we want the limit as x goes to infinity of, not f of x, g of x, and the limit as x goes to negative infinity of g of x. So looking at our ends, as x goes to positive infinity, the function goes to positive infinity. As x goes to negative infinity, the function goes to 7. Because we've got this asymptote here at 7. So there's our end behavior. And then we want to do a quick sketch of the function. So we would probably want to put, that there's an asymptote at 7. We would want to put our y-intercept, stuff like that. So let's go ahead and draw that. I've got our asymptote. We'll make sure we label it. That's 7. So we should have something looking approximately like that. And again, this is just a rough sketch. All right, so that's what we're expected to do for number 2. Any questions with number 2? Okay. Then we will move on to number 3. Number 3 has 2 parts, and it's both that we're supposed to condense the logarithmic expression. So that's what we'll be doing next. 3a, we're condensing 3 natural log of x plus 4 natural log of 2 minus natural log of 5y down into being in terms of a single log. So first we notice that yes, all of these are natural logs. So since they're in the same base, we can start working here. So what I would do to start with is move all of this multipliers out front into the exponent. So we get natural log of x cubed plus natural log of 2 to the 4th minus natural log of 5y. And then 2 to the 4th is 16. So I would just go ahead and replace that with 16 as well. All right. Then from there, we have to start condensing with the product and quotient properties. So we're just doing that left to right. So we'd get, combining these two, natural log of 16x to the 3rd. And then combining these two, natural log of 16x to the 3rd over 5y. And that's our answer. And then 3b. 3b is 4 log base 2 of d minus 3 log base 2 of c minus log base 2 of b. And we want to condense that as well. So for this one, we're starting the same way, moving the exponent or the multiplier out in front to the exponent. So we get log base 2 of d to the 4th minus log base 2 of c to the third minus log base 2 of b. Then we're combining left to right. So since it's subtraction in the middle, log base 2 of d to the fourth over c to the third minus log base 2 of b. Then combining these two, log base 2 of d to the fourth over c to the third over b. But really, when you've got something like this, that's equivalent to log base 2 of d to the fourth over c to the third b. So this is the way we would want to write our answer. We don't want something like that. All right, any questions from 3A or B? Remember, subtraction is the quotient property, addition is the product property. Okay. Then lastly, moving into 4, 5, and 6. 4 and 5 are both rewriting expressions in either exponential or logarithmic form. And then 6 is about evaluating a logarithm. So here we go. Number 4. We are given log base 2 of 16 equals 4, and we are expected to rewrite this in exponential form. So if you can remember what exponential form is supposed to look like, and you just want to go directly for it and go, all right, this number is supposed to be in the base, this number was supposed to be the exponent, this number is supposed to go to the other side of the equal sign. You can do it just like that if you would like. If remembering where the numbers go is kind of difficult, though, or you don't want to take that risk, remember you can always take whatever number's in the base here and put that underneath both sides, because the 2 will cancel out the log 2. And you'll just be left with 16 equals 2 to the fourth. I'm okay with either of these representations because they're the same thing. So that's number 4. Five is similar. We have 3 to the negative fourth equals 1 over 81. And we're supposed to rewrite it in log form. All right. So rewriting things as a log, you're just kind of reverse engineering this process here. So one way that you could do it, just like with the previous one, is you could, if you want to just remember where things go, you can go, okay, this number is in the base of the exponent, so it's going to be in the base of my log. This number was over here, so it's going to end up there. And this number is going to end up, the exponent is going to end up as the other side of the equal sign there. So if you want to remember it like that, you totally can. Otherwise, there's something else you could do. You could remember that if I want to get something out of the exponent, then I need to log it. And in particular, since the base of my exponent is 3, then I want to log base 3 it. So if I log 3 on both sides, the log base 3 cancels out the 3. And you're left with negative 4 equals log base 3 of 1 over 81. So we get the same thing either way. Whichever way that helps you remember it the best is totally fine. So there's 4 and 5. Those ones are pretty similar to one another. Any questions on 4 or 5? Okay. Then the last question, number 6. Evaluate the logarithm. So the logarithm we're supposed to evaluate, log base 3 of 47. This is probably the easiest one because it says round to 3 decimal places, giving you the hint that this is not going to be a nice number. And then we should just type this into the calculator. You could use the change of base formula if you would like, but again, now that we have good enough calculators, that's kind of a waste of time for this. So just for the purpose of evaluating a log. So log base 3 of 47 is 3.5045, so that would round to 3.505 if we're rounding to 3 decimals. But again, if you wanted to, you could do the change of base formula if you just want some practice with the change of base formula for funsies. You could definitely do that, and you would type in either log or natural log, doesn't matter, log 47 over log 3 into the calculator, and that would get you the same thing. Okay, so that's the entire thing. Tomorrow on your quiz, you'll also have the Flipgrid component, and on the Flipgrid component, you'll be asked to pick a problem from 1A, 1B, 2, 3A, 3B, 4, or 5, and do that in your Flipgrid question. Any questions about anything on the practice quiz? Anything we want to go back to? Anything at all? All right. Well, that's everything I've got for you. So I will post the exit ticket in a couple minutes, but you guys are free to head on out. If you have more questions, feel free to stick around. Otherwise, have a good one. I'll see you tomorrow.